afternoon, ma'am. Good afternoon, everyone. Today, I'm excited to share the machine learning model which I have developed for fraud detection transactions, which happens on credit card companies. So today, I'll walk you through over the next few minutes. I'll walk you through the implementation methodologies and the impact which I aim to achieve. So recent machine learning advancements today we can see in O3 model, which is released by OpenAI, and Gemini has released the Flash 1.2 with the model which combines all three variants: text, audio, and video, which gives you inputs as well as outputs for the images, audio, video, and text understanding. And e-commerce also has, we can see the machine learning advancements which they use to more marketing, understanding the customers completely to give more customer oriented and solution oriented products. It is not the strongest of the species that survive, nor the most intelligent, but the most responsive to change. That is the quote of Charles. So today I'm descriptively detecting fraudulent transactions with machine learning. The ML models I used are two ML models, which are logistic regression and random forest classifier. Credit dataset sources goes to Kaggle. So, if you take a look at the data set which I have downloaded from the Kaggle, the all the data set has non-null values, and all are have no missing values in it. So we can say this is a completely 100% clean data. So as you can see here, we can see the column named as V12, V18, V19. This is to completely protect the integrity of the transactions and the privacy. So we completely do a PCA, which is principal component analysis, which converts the confidential data into a variant data, which don't lose the information and the characteristics, but the hides the privacy uh, privacy of it. So today, so fraudulent versus non-fraudulent. So this is the beginning of EDA. This is exploiting data analysis, distribution of the target value, which is class value. So in class value, we can see zero is it's non-fraudulent, non-frauds, and one is a fraud transactions. So we can clearly see this is a imbalance, highly imbalanced data, which has extreme outliers, and understanding imbalance is important as a standard accuracy which is represented by zero class is 99.83. So if we don't look after the imbalance which is propagated by class 1, that is frauds, we might mislead the information which is propagated by the class 0. So we need to consider and implement methodologies of to handle this imbalance, which we can see in this fraud detection data set. So this is amount. This is amount distribution. So this is again a EDA process, part of EDA process. This is the distribution over the transactions about with the count of the transactions and with the amount of the transaction within it. So we can see there are multiple transactions are below 5,000, and there are extreme outliers which go 25,000 and above. So this is highly skewed, and many small values transaction are there. So this has non-fraudulent transactions, which are 99.83, which is highly skewed, which equals to 22 lakh 84,350 transactions, and against it 0.17 fraudulent transactions 492. So this is a really interesting case study which I came across, because this has highly extremely skewed distribution, which you can see completely here. On the next slide, we can see the matrix of the correlation between the components, or the V1 to V28 components, and the time and amount component as well. So here you can see amount resonates and correlate with the V7 and V20 component. So this, even though this V1 to V28 are PCA, which are principal component analytic transformed, as the information loss is minimal because there is a eigenvalue vector and eigenvalues are converted into it, so they lose really minimum value with more information providing it. So this may potentially correlate with the amount or the amount with the amount or among themselves. So here we see for a searching pattern, we try to recognize correlation between the principal component analytics transform which are transformed and with the time amount. So we can see here there are multiple shapes and the scattered plot of all within the components, and this orange represents the frauds and the blue represents the accurate or the non-frauds. So we can see this is really highly skewed. Here also we can see this is really imbalanced distribution. So we need to take care measures for this. So this is challenge. So how do we handle this challenge? So we can see amount by class also. So this zero non fraudulent transactions have outliers and they are more high numbers, and while the low fraudulence fraudulent transactions have strength low. So how do we handle this? This outlier should be considered as they are include suspicious large value. So basically, if we do a general analysis or EDA for any data set, we try to minimize the outlier to potentially reduce the increase the accuracy of the resultant prediction. But in this case, we need to consider the outlier because they might contain some information which we can further add for the model to analyze and predict. So this outliers, or this outliers are 1% outlier. This fraudulent transactions are only 1%, and they are just there in very few, like among like only 500 of transactions have done with fraud detection, with actually fraud, which are actually fraud. So aspect and impact. So model choice. This 1% actually impacts a lot on various aspects. As you can see, more model choice heavily influenced by class imbalance. We have seen previously the class imbalance about the amount and the actual fraud transactions. Sampling strategy, we can have impact guided by imbalance exploration, and evaluation matrices heavily influenced by class imbalance. So on the next, we see overtime duration. So why I have plotted a overtime duration of transactions? Because this is a batch which is taken from a random day in a random hour, and the zero represents the seconds to the 1,75,000 seconds, and the 0 to 10,000 are the count of the transactions of that made during that period of time. As you can see, from 75 random seconds, 75,000 at the 75,000 seconds, we see the maximum spike in the count of transaction. Ma'am, ma'am, am I audible?
Yes, Monish.
So this is a complete EDA practices which I've done and explained throughout just now. So data exploration, it is done to in fraud detection context. Shape and info just quickly knows about the data and the shape of the data and how the data is well distributed. Description is statistical overview, gives you five central tendencies measure, how you can measure on what that basis you can conclude that this is the outlier and this is the mean median. Class distributions, most vital step in fraud detection. Histogram box plots or reveal distributions, skewness, and the outliers might affect and the imbalance which we can see in the class and the amount. Pair plot, we have seen the we have seen the scatter plot among the 30 columns. Correlation heat map we have seen in the correlating with the amount and the V7 and V28 column. Balancing insights reinforces the need to handle the skewed classes, which we'll see now. Balancing insights we will see now. So this is the preparation before modeling. So we need to prepare the data to process in the model so that the model will not be biased and will give you more accuracy over it. This first step is isolation. This is the before step, the step before we give the data to model. This is isolation. So we isolate. So as the data is really highly imbalanced, we need to somehow equate the data, weigh the data with other component. So I have weighed the data with the zero, as the zero had a minimum 492, one had a 492 transactions total, but zero had a really big value, 2 lakh. So we need to compress the data. We need to train the trace. We need to separate the data as such that that won't affect the model, or won't be a biased model. So we need a completely unbiased model. So we need to give the data as like that. So the problem we had faced is data imbalance and model bias. And description, the result solution we can have, the data contains significantly more non fraud cases than fraud cases. That is the reason. And for model bias, class imbalance can lead the model to prioritize majority classes, accuracy over minority classes. So we need to focus on minority classes, which is one. If we don't do this, we will be focusing on the 1 0, which is accuracy, which are not minority but the majority classes. We need to equate a majority class with the minority class. So we go ahead with the undersampling. So to address this imbalance, we go with the undersampling. So this is the split method, split stage where we split the data for training and testing purpose from proper testing and proper scaling. So prevent data leakage where knowledge of the test data creeps into the training. That's why we split the data, and avoid for scaling, avoid letting large scale features such as we have seen the class 0, which was dominating at the model. If we don't isolate it, and the if we don't if we don't maintain the balance, we might just expose to the most biased model. So we to prevent this, we do a smaller scale features and avoid the larger scale to dominate over the small scale. So we do scaling in this regard. So we can see the train data and the test data here. So this is the first introduction of logistic regression in this case study. So this logistic regression deals with linear variables mostly, and it gives you the more classified, or you can say more categorical in 0 or 1 prediction. So these are the steps which I took for the model initialization, initializing the logistic regression model, fitting the model with the coefficient, and understanding the training the coefficients in the model. That is the fitting the model. Predicting on the data, we can have a 0 1 as the data prediction gives you the predicted data. Interpretability is logistic regression coefficients provide interpretability. Handling imbalances using class weight balance, which we can see in the next part, that is code implementation, where we can see class weight is equal to balance to address the class imbalance. So we need to imbalance. The main challenge is to class imbalance. We need to balance the class which is more biased. uh, Here I introduce second model to increase the accuracy of the resultant prediction. I need to take consider that this is a linear, but we have seen outliers. So when we have outliers, a lot of outlier, and we can't eliminate, we don't want to eliminate, but we rather want to consider it to the prediction to make the prediction more accurate. So I had introduced the random forest model, which is a classifier basically, but it can detect and it can work along with the non-linear variables, which have random most outliers. So about this random forest, this is a model initialization where we can initialize a model with the random forest classifier, mentioning everything inside the parenthesis, fitting the model, assembling the decision tree to it, and predict the test data. in form of 0 and 1. So why is two machine learning models? Because to predict the more accuracy on this fraud detection. The reason I took the two major models because we have highly skewed data and highly imbalanced. So we need to consider the outliers and the highly imbalanced skewed also. So to give the accurate result, I have used two models. So evaluation of those models. So uh, this is the evaluation which we will see in the code implementation. This is the report, and this is the performance comparison between the two models. So evaluation is basically here, ma'am. This evaluation is actually in code implementation. Should I go to code?
Yes, yes. Okay.
So, uh, so here we can see this evaluation. This is a logistic training for the logistic, and this is evaluated with the results.
Please give your name and
So okay, so this is the second model, random forest model again, which I'm training and evaluating the results. Above, we can proceed with the this evaluation model, and then we have the results of the evaluation of the second model. So final evaluation, we see this is a fine tuning which I have used in this model, which we I didn't found any interesting or didn't improve the prediction. So this is completely optional hyperparameter tuning and result interpretation. So this is the resultant interpretations. We can see the precision recall curve and then the recall itself, and this is the performance comparison. So again, I go back to this to explain in detail. So this is cell. So we see the 141 value in the resultant output. So what is it? It is a true negative. Actual class is 0 and predict class is 0. Top right, that's a 7 value. We can see false positive, which is the model has predicted the false positive, which actually is 0 and predicted class 1. So it is a complete false positive. So bottom two values in the matrix are false negative and true positive. So false negative is basically actual class is 1 but the predicted is 0, and bottom right is true positive, actual class is 1 and predicted class is also 1. So this is the matrix. This is the output of the evaluation. So what it means, the classification report, that the precision has class 0 and class 1 95%, 92%. So precision is that these are actually predicted values. That is the 92% is actually predicted, and 95% of the data is actually predicted. Class 1, that is fraudulent, and 92% are non-fraudulent. Recall is a terminology which we can say for a predicted analysis, that the actual out of actual class 0 samples, we can say 95% are correctly predicted, and as a 0, all actual class samples 91% are actually predicted as class 1. So if the higher recall value is the fewer false negative, so we need to eliminate the false negative. F1 score is a harmonic mean of precision and recall. So this is a combination of calculation of precision and recall, and this gives a F1 score, a measure of precision and recall, and is useful when precision and recall are important. Support for each class is 148 samples, so the data is highly is balanced now. So macro. So this is the other terminology which are not so important, but this is the 93 percentage macro average treats as a class equally. Simple average, it is weights of the support. This is the curve. This is the curve. You can see the recall and the precision, and this is the final model performance of over there. And I found out that this is 98% accuracy over the final output. The things I learned into this, I have to how to use confidential data without losing its integrity and information, and how to retain maximum information from highly skewed data set, and how do we combine the two models to increase the prediction accuracy. So, yes, ma'am. Thank you. So this is the end of it.
Okay. So this is your project? Yes, Monish?
No, ma'am.
No.
That is image.
Okay, good. You presented well. This is actually the way of presentation. Okay.
No,
So, but
actually, yes, this should be here. Actually, few
Hmm.
slides was up front.
Mm. So that is others also for reviews and all you follow this way. First, you need to clearly say what you are going to do as well as what you have done. Okay, that you need to clearly give a picture to the listeners. Then you show your demo and output discussion. So like that it should be. Okay.
Okay, ma'am.
That by seeing that last slide, I doubted. So the same project presentation have you given here?
No, ma'am.
Forgot you.
That would be different.
Mm. So next week we can have a review. Okay. Yes.
Okay, ma'am.
By 31st. I set some date.
No, ma'am.
No. So Monday or Tuesday we can have. Okay.
Okay.
What about no that Magesh and Kiran not